Hello everyone, this is James with the Vedder VESC, and today I'm going to be demonstrating me loading the firmware onto my chips. I actually had these manufactured, so I wanted to show anybody who was interested in the process of me doing so for transparency's sake. Here we have Ubuntu 14.04 loaded onto my MacBook Pro, and down here I have a few VESCs which I'll be loading the firmware on today, and you can see them here. I have one here which I have in my hand that does have a soldered servo connection here on there, and I just wanted to show you guys that it's not connected to anything, so don't worry about this if you see this on this one. So today I'll be connecting the STM32F4 discovery board to each one of the chips using the programming port, which will be this 6-pin JST port. And we'll go ahead and just connect it there firmly. As you can see, the wiring diagram is like so, with the green coming out on the 3-volt VCC here, and the jumpers taken off the ST-Link portion of the discovery board. With the terminal open and having all of the dependencies installed, as well as the firmware cloned from the GitHub, I'm going to go ahead and enter the firmware directory and use the command make upload to start loading the firmware onto the chip. As you can see, the programming is started. I've already had the firmware loaded onto the device, so you can see auto erase has been enabled. So it's basically erasing the current firmware and rewriting it with the new firmware, verifying the program has finished, and verifying the size of the actual file, and shutting down with the shutdown command. So that's the first VESC programmed. We'll go ahead now and disconnect and set aside over here and move on to the next. Again, connecting firmly into the programming port and just running the command make upload. Programming enabled, or sorry, programming started with the erase enabled. And verifying and finished. It's that simple, so I'll move on to the next. We have 6 boards I'll be uploading the firmware to today. And I'd like to note, if you happen to have an issue uploading your firmware, say it happens to have a OpenOCD initialization failure, don't worry, just try again. Maybe close your terminal, restart it, and try. Or you can maybe move on to another VESC if you have one, and then go back to the one that failed. I noticed that the ST-Link sometimes has a failure programming with the OpenOCD, so there you guys go. That's the third one. Move on to the next. Also ensure too that when you do solder up your JST connector to your discovery board, that you don't make this lead extensively long, that it's relatively short. Let's move on to this next one. Again, running the command make upload. There we go. Like I was saying, if you guys happen to see the OpenOCD initialization failure, don't worry, that happens periodically. Just either move on or try it again. Let's try it again here before we move on. Yeah, it fails. I noticed that happens sometimes. What I'll do is I'll just restart the terminal and try it again. In this case, we'll just try it again at the end, and if it doesn't, no worries. I'm well aware that all these chips do in fact load their firmware, as I've already loaded them, but here we go. Chip number 4. Attempt number 5. There we go. Programming is started. Finished and verified. Everything's okay. Moving on to the next board. Again, running the command make upload, and programming is started, auto erase enabled. Verified and finished. So no issues except for this one, loading the firmware. But as you see, like I said, just give it another try and it will program. It's just a matter of either resetting the dependencies of some sort. Something's going on with a little hiccup there. But again, I'd just like to note for everybody who does happen to run in that, to don't be discouraged and don't necessarily go running around on the internet trying to figure out a fix. Basically what you need to do is either close your terminal, reopen it again and try it, or just move on to another VESC if you guys are running maybe dual speed controllers or maybe quad speed controllers, and then just come back to it. As you see, all our VESCs uploaded the firmware successfully from the final ones that I have remaining in stock here, so no problem getting the firmware installed. The only issue here is the what I believe is connecting to the BLDC tool, is that this is actually the wrong USB connector. Vedder has the USB connector. Actually, these connections are actually reversed than a normal USB connector, so the one that I received from the manufacturer was sourced as the wrong one, so I'll go ahead and just have these replaced I'll order them from Mouser, from the bill of materials, and replace them all on these, and then we'll go ahead and catch back up with you guys for another update on checking the motor test. So hopefully you enjoyed the video. I'm James, and this is the Vedder ESC. Again, I had these produced from open source hardware and open source software. I used a Chinese manufacturer, and my experience has been pretty fun so far with this little project. I've had to reflow a few components, rearrange some diodes, swap some capacitors with resistors that were mixed up, and add these shunts on there. Looks like we'll go ahead and add the USB port, and that should finalize everything. Everything else looks good, so here we go. Until next time, you guys. We'll see you.